Okay, so for this one, we've got, you know, like you think about years and half-lives and all that stuff. And then amount remaining. I'm just going to kind of like maybe do just one half-life, just to get us into the thinking of what's going on here. So, because we've gone through, one half-life is going to be 7,370 years. And the amount remaining is 54 times a half, you know, whatever that is, 37 grams, right? Now for, you know, for fun, I'll just do 10 half-lives just because we've gone over these quite a bit. And that's going to be 73,700 years, right? It'll be 54 times a half to the power of what? 10, right? And whatever that is, right? So for our problem, it is 10,000 years. So we first have to convert that to half-lives. So how many half-lives is that? Okay, so you go 10,000, and you go, how many half-lives are contained in 10,000 years? Each half-life is 7,370 years, so you just do that. Over 10,000 divided by 7370. I'm just going to say it's roughly 1.36. I'll just round it, just for fun. It's all just a bit of an estimate. I don't really mind. We'll be a little bit off, but not too bad. But I hope this makes sense because look, 7,300 something years is one half-life. So 10,000 is actually just a little bit more than 7,000. So I hope it makes sense that your half-lives is about 1 point something. Does that make sense at least? Okay. And so then, you know, your formula is 54 times a half to the power of 1.36. And in a calculator, 54 times 0.5 to the power of 1.36, right? And if you wanted to be super accurate and not have any errors at all, you would go 54 times 0.5 to the power of parenthesis 10,000 over 7370, and that will give you it. So I'll just go ahead and do that then. So 54 times 0.5 to the power of parenthesis 10,000 over 7370, and I'm just going to round that to the nearest gram. It should be roughly 21 grams remaining. So we started with 54. So now we start with 54 grams. And after this many half-lives, this many years, 10,000 years is 1.36 half-lives. It's 21 grams remaining of the 54, right? Cool. And how badly would it be if we just did the 1.36? Probably about the same thing. 1.36. Yeah, basically 21. So yeah, 21 grams, whether you do it this way or this way. Obviously, this way is the most accurate, right? $10,000. Yeah. By how? Yeah. Yeah. I wanted to know how many half-lives in 10,000 years, right? How many half-lives are contained in 10,000 years? That's what I was doing, and this is kind of like a math application of division, which most people aren't able to do. They're not able to apply division in real life. You know, that's one of the problems. So it's a good skill, but like you're literally saying how many of these things are contained in 10,000 to get the number of half-lives, which is 1.36, right? Yep.